Alrighty, so we are continuing our quest to solve for inequalities. So we are in section 6.4, and 6.4 concentrates on solving compound inequalities. Compound inequalities are two separate inequalities joined together by what are called and, which is right here, or statements. Now you're probably asking, what are and or statements? Here's an example. So let's say that I have uh, two inequalities here. I have x is greater than -2, and I have x is less than or equal to 1. So if I were to just graph these separately, so I have -2 here, I'll put in -1 and a -3. This one's with an open circle, and it opens up to the right. And for x is less than or equal to -1, or yeah, just 1, I'm sorry, which we have 1, 2, and 0. This is a closed circle, and it is shaded to the right, or to the left, I'm sorry. So now what if you were given a statement that looked like this, where x is greater than -2 and x is less than or equal to 1. You could also see it written like this. If you see something like this where -2 is less than x, but x is less than or equal to 1, that is also another way to write an and statement. So that's an and statement. And how you graph it like this is put my -2 here and my 1 here. So I'm going to put one that's larger than 1, which is 2, and one that's smaller than -2, so that's what? A -3. And the for the -2, it is a open circle. For the 1, it's a closed circle. And you're looking for a value for x that is both larger than -1, but smaller or equal to 1. And so the shading for this kind of looks like this. It's shaded in between the inequality. And that makes sense because if you look at the top here on this graph right here, my -2 is shaded to my right, and for this graph here, the one that's in 1 is shaded to the left. And so for these statements to be true for x, it must be in between -2 and 1. Now let's take a look at an or statement. So let's say I have x is less than -1. So we know how to graph this. We have 0, we have -2. This is an open circle, and it's shaded to the left. We have x is greater than or equal to 0. So I have 0, I have 1, and I have -1. This is a closed circle, and it's opening up to the right. So you get a statement that looks very similar to this, is an or statement. You'll have, I want to find the value of x that's less than -1, or x is greater than or equal to 0. So I have my -1, got my 0, put 1 here that's larger than 0, and then I'll put -2 that's less than um, -1. And an or statement, when you graph it, looks something like this. So I have a closed circle here, and it'll be shaded to my right. and I have my -1, which is an open circle, and it's shaded to my left. So if you remember from the first page, the and statement had the shading in between the two solutions for the inequality, and the or statements are shaded on the outside. So that'll help you kind of remember and statements you shade inside the inequality, inside the shade of the inequality, or statements you shade on the outside. So let's take what we've learned from and or statements and apply them to solving inequalities and also graphing the solution. So I have A, which is, this is an and statement right here, because that's one way to write an and statement. So if you remember, we keep that in mind when we graph it, our shading should be in the middle. So let's make sure that that holds true. So I have -5 is less than or equal to -x minus 3, which is also less than or equal to 2. So first thing I want to do is, these are actually two statements here. It would, if you were to rewrite this problem, it would be like saying -x is less than or equal to -x minus 3. And another way to write this, it would be -x minus 3 is less than or equal to 2. So I'm going to keep that in mind. So I'm going to solve this first one. So I'm going to add 3 to both sides, which then gives me -2, which is then less than or equal to -x. But I'm going to multiply both sides by -1, and that gives me 2. And by doing that, I have to flip the inequality because of the weird rule, and I have 2 is greater than or equal to x. So let me just add 3 here. That cancels. Got x. I got greater than or equal to 5. I want my variable to be without a negative, so I'm going to multiply by -1. I got my x here now. I got to use the weird rule again, and it'll be a -5. So I need to flip. I'm going to flip this so I have x. Carrot stick is over there, and 2. So now that I have these solutions here, I can now graph them. So I have a -5. That's the smaller of the 2, and I got 2. I'm going to put 3 over here, and I'm going to have a -6. And it should hold true. So say if this is an and statement, they're both closed circles. And if we look at this one here, it should be shaded to the left-hand side, which that holds true, and this one should be shaded to the right. So that's where we get our shading in the center. So let's look at B. So I have, this one just shows up as two problems, where it has 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. So let's solve the first one. So I'm going to subtract 3 to both sides, cancels that out, which gives me 2x is less than 6. Divide both sides by 2, which gives me x is less than 3. So let's look at this one where we got 3x minus 6 is greater than 12. I'm going to add 6 to both sides. That cancels that out, so now I have 3x is greater than 18. I'm going to divide 3 to both sides, which then gives me x is greater than 6. So dealing with the inequality is we have 3 here. We're going to put a 6 on this side, and they are both open circles. And if you look at my x is less than 3, I am going to be shading to my left. And for x is greater than 6, I'm going to shade to my right. And this holds true for my OR statements, because I said before, OR statements you shade on the outside, and statements you shade in between them. And those are the solutions that we are looking for example B. Last one's a story problem. Let me get some, oh, too far. So the story problem is I have 5 more than x is less than 8, or 3 less than x is greater than 5. So let's try to figure this out. So I have 5 more. So that sounds like a addition. So I'm going to put 5 plus x is less than, so that means I'm going to have my less than sign is less than 8, or, which means this is going to be an or statement, 3 less than x, so it's going to be 3 minus x is greater than 5. So since I've was able to decode the story problem, and now I can solve the inequalities. So I'm going to subtract 5 to both sides, which gives me x is less than 3. And this one here, I'm going to go minus 3, which gives me negative x greater than 2. And I'm going to multiply by negative 1, multiply by negative 1, which gives me x. Flip the inequality. Is, wait a minute. I'm sorry, I actually did something wrong. And I did it wrong on this equation. I read it wrong. So, as I said before, I wrote it as 3 minus x. It should have been x minus 3 is greater than 5. It's my bad. I messed up. And if I wanted to add 3 to both sides, which is x is greater than 8. Apologize for the confusion. And I corrected it. So if I were to graph this, so I have a 3 here, I have an 8 here, let's put like a 9 and 2. So they're both open circles, and I'm going to be shading to the right hand side, and I'm going to be shading to the left on this one, which holds true for my ands and or statements. So quick things to remember. And statements have 2 different ways you can write them, or at least be able to read them or identify them. When you're graphing and statements, they are shaded in the middle of the 2 solutions of the inequalities, and or statements, when you graph them, they're shaded on the outside. So I hope this helps, and until next time.